Many people know that black holes are objects in deep space that absorb objects irreversibly, with no possibility of recovery. However, what if we told you that we actually live inside a black hole? We follow one of today's most prominent scientists, Michio Kaku, as he reveals this shocking truth. Our existence occurs inside a supermassive black hole. Plus, he discusses new images from the James Webb Space Telescope that contradict the erroneous Big Bang theories. Join us to see what Michio Kaku has to tell us, and we explore these exciting new images made by the James Webb Space Telescope that contradict the Big Bang theory. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Have you ever believed something for a long time and then realized it wasn't true? You probably don't mention the Big Bang, since it's a fairly popular explanation for how we got here. However, with the advent of the James Webb Space Telescope, the Big Bang theory is being challenged. James Webb has made observations that are forcing astronomers to reconsider their ideas about the origin of the universe. Theoretical physicist Michio Kaku describes the latest shocking discoveries from the JWST this way. The problem is that the James Webb Space Telescope is shaking the established foundations. Suddenly, we realize that we may have to rewrite all the textbooks on the origin of the universe. What is the latest accurate JWST discovery that has led eminent scientists to rethink the origin of the universe? Here's the revelation. JWST has identified 6 galaxies that exist a billion years after the Big Bang and 10 times larger than the Milky Way. This is surprising, since it normally takes billions of years to create a galaxy like ours, with hundreds of billions of stars. The James Webb Telescope is challenging our preconceptions and making scientists reconsider the origin of the universe. However, the question arises, why does the discovery of these 6 galaxies contradict the conventional description of the origin of the universe? These galaxies should not be larger than the Milky Way, which is only 500 million years old. Something doesn't add up, and perhaps we need to revise our theory of the creation of the universe. The galaxies mentioned by Michio Kaku, which contain hundreds of billions of stars, arose when the universe was only 500 to 700 million years old. This is significantly earlier and faster than expected from current models of formation, which suggest that things gradually clump together over time. The enigma of how these galaxies formed so quickly may require a new understanding of physics or new techniques to explain their creation. The discovery of these challenging galaxies was made by a team of astronomers led by Ivo Lobby of Melbourne University of Technology, Australia, using the first JWS photos released in July 2022. They captured images of a patch of sky 100 times smaller than the full moon. These images were obtained with the NearCam camera, one of the JWST-4 main instruments. This camera makes it possible to observe objects at infrared wavelengths, stretched due to the expansion of the universe, which are invisible to other telescopes due to their faintness and remoteness. The researchers discovered about 1,000 exceptionally bright red objects in these near-rear cameras images. They used a technique called photometric redshift estimation to calculate the distance between each object based on how much light has been redshifted due to the cosmic expansion. 6 of these objects had extremely high redshift between 9.5 and 11.5. This implies that their light is just over 700 million years old, compared to the most distant confirmed galaxies, which has a redshift of 11.1 and was discovered in 2016 by the Hubble Space Telescope. Using stellar evolution models, the scientists calculated how many stars each of these galaxies would need to emit all their light. They found that the stellar masses of these 6 galaxies range from 10 to 100 billion times the mass of our Sun. This is comparable to, or even greater than, the mass of our own Milky Way galaxy, which contains approximately 6 billion stars and has had more than 13 billion years to grow. These findings are surprisingly and puzzling for several reasons. First, they imply that these galaxies originated rapidly and efficiently in a short period of time, transforming most of their available gas into stars. This contrasts with the conventional view of galaxy formation, which predicts that galaxies start small and gradually grow by merging with other galaxies or by accreting gas from their surroundings. Second, these observations contradict cosmological theories based on the study of the cosmic microwave background of the Big Bang, which indicate that these galaxies have more disorder than was accessible in the regions of space at the time. Third, the fact that these galaxies have already produced large numbers of old red stars implies that they have undergone numerous generations of star formation and chemical enrichment. This raises questions about how stars arise and grow in a pristine environment. One possibility is that the measurements or assumptions on which these observations are based are incorrect. It is possible that these objects are not galaxies, but rather quasars or other types of active galactic nuclei, AGN, powered by supermassive black holes. AGNs may appear incredibly bright and have a redshift similar to distant galaxies. However, this situation seems unlikely due to the differences in the spectra of AGNs compared to these objects. In addition, supermassive black holes need time to form, so AGNs with such high redshift are expected to be rare. Another possibility is that there is an error in the models or theories used to interpret the observations. For example, these galaxies could have evolved through a different mechanism that we currently understand, such as direct collapse or extreme instability. These processes have the potential to produce huge galaxies in a short period of time without relying on mergers or accretion. Alternatively, these galaxies could be exceptional cases or abnormalities that developed under unusual conditions or in particular regions of space, rather than being representative of the general population at the time. In this case, more observations and larger samples would be needed to validate their presence and quantify their frequency. Another option, however, is that something is wrong with our current cosmology or physics. These galaxies could provide evidence for new events or interactions that are not covered by our normal cosmological model, such as dark matter annihilation or primordial density fluctuations. These factors could influence the volume and distribution of matter in the universe, causing more mass and faster expansion in some places than in others. Alternatively, these galaxies could be evidence for additional dimensions or forces that are not included in our current model of physics, such as string theory or modified gravity. These concepts could have an impact on how light travels through space and time, altering its perceived brightness and redshift. However, these are all theoretical possibilities that would require further research and evidence to confirm. However, Michio Kaku has an explanation for the latest discoveries involving black holes detected by the JWST. According to him, these are not baby galaxies, but monster black holes. This idea puzzled scientists because it does not fit the normal sequence of the birth of a galaxy. Kaku suggests that these black holes could be places where new laws of physics emerge. If someone manages to figure this all out, there could be a Nobel Prize waiting for them. In addition, there is a related theory that proposes that our universe is a giant black hole. According to this theory, our universe was created by the collapse of a giant black hole into another, larger cosmos. The event horizon of a black hole is a point of no return where nothing can escape its gravitational force. Within the event horizon, gravity distorts and twists space-time, creating a singularity where density and curvature become infinite. Some scientists suggest that instead of a singularity, there could be another event horizon inside the black hole, leading to a world with different physical rules. This idea implies that our universe is nested inside a black hole, which in turn could be inside another universe. According to this hypothesis, black holes are not only one-way traps, but also portals to other domains of space and time. Although some theoretical models and mathematical calculations support this hypothesis, it has not yet been validated by observations or experiments. Currently, one of the main objectives of this theory is to answer the question of what happened before the Big Bang, which is commonly recognized as the origin of our universe. What do you think? Let us know in the comments box. Remember to like the video if you liked it and subscribe to not miss more valuable content like this. And we'll see you in the next video.